Sometimes we have a limit where x is approaching infinity or negative infinity. So if we look at this chart that we have over here, here we have an example on the top of where x is approaching infinity. So using direct substitution, if I were to plug in infinity, so n is just some number greater than 0. So for purposes, I'm just going to call it 3. If I were to plug infinity in, infinity to the third power is always going to be infinity. So infinity to any power that's greater than 0 will be infinity. Here they're saying, okay, well, what if you have a negative exponent? So based off of the rules of exponents, we know that a negative exponent can be rewritten as 1 over the base to the positive exponent. So if I were to plug in infinity here, and again, I'm just going to use where n is 3, right? If I plug in 1 over infinity to the third, right, that's just like 1 over infinity. The higher the number is in the denominator of a fraction, the closer the number gets to 0 overall. So for instance, if I had, let's say 1/10, right, that's a smallish fraction. If I increase the denominator, let's say 1 over 100, that's an even smaller fraction. If I increase it again, let's say 1 over 1,000, okay, it's getting smaller and smaller and smaller. The overall fraction is getting closer and closer to 0. So anytime that you have a limit where x is approaching infinity and it's going to an exponent that is negative, it's going to overall be approaching 0. Now here, the bottom part is saying, well, what if x is approaching negative infinity? So it's the same idea. So here, if you just have a regular exponent that's greater than 0, if you plug in negative infinity, it depends whether that exponent is even or odd. So if I plug in positive infinity, negative infinity and an even exponent, okay, my overall value is going to be a positive infinity. So for instance, negative infinity, if I raise it to the second power, because of that being squared, like negative infinity times negative infinity, that's going to equal positive infinity. But if my exponent is odd, like negative infinity to the third, then I will have a negative infinity, just like with numbers. So if I had, negative 2 squared, I get positive 4. But if I had negative 2 to the third, I would get negative 8. So it really depends on the even or odd of the degree. And then for when you have an exponent that's negative, similar to what we did when it was positive infinity, same idea. We're going to change it to be 1 over x to the positive n. And now if I plug in negative infinity here, right, it doesn't matter what number I'm using. So negative infinity to the whatever, it could be even or odd, it doesn't really matter. When I have 1 over a very, 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 very small number, because it's going to be negative, so a very large negative number, it's still going to get closer and closer to 0 just from the other side. So a large number in the denominator is going to make the overall limit get closer and closer to 0. Okay, so using those ideas, we're going to try this example, and we're going to, for right now, use our limit laws. So we're going to kind of split this up a little bit. So we're going to say the limit as x approaches infinity. And then we have 3 minus, so I'm going to separate this. So I'm going to pull out this constant. So this is from the video from the other class. So I'm just going to rewrite this using limit laws. And so x to the negative third is the same thing as saying 1 over x to the third. I'm just changing it to that positive exponent. And then plus 5 times the limit as x approaches infinity. X to the negative 5 would be 1 over x to the fifth. So now I'm going to plug in infinity. I'm going to use direct substitution. So here there's nothing to substitute in because there's no variable. So that's going to stay 3. Then I have minus 4. I'm going to put a parenthesis here. Times the limit as x approaches infinity of 1 over x cubed. So I'm going to plug in infinity here. And this is similar to this idea up top here. This one. Oops. Right? So I have 1 over infinity. So that's going to just approach 0. And then I have plus 5 times the limit as x approaches infinity of 1 over x to the fifth. And again, that's similar to that situation. 1 over infinity is just going to get closer and closer to 0. So this ends up just being 3. So let's kind of rewind for a minute and think about horizontal and vertical asymptotes. So this is something that you should have done in Algebra 2 and in pre-calculus. Before we look at this exact problem, let's just kind of remember what they are. So for the horizontal asymptote, you want to make sure that you're checking your degree. So I'm just going to write check degree. And remember that your degree is the highest exponent. So when you check the degree, there's really three things that could happen, right? The top degree of the numerator can be greater than the bottom. So top is greater than bottom. When that happens, the horizontal asymptote is none, right? When the top is bigger. The other option here, option 2, is what happens when the top is equal to the bottom. So when the top and the bottom are equal, what we do is we have our horizontal asymptote is y equals the ratio of the coefficients. And if you remember that, that's just the highest exponent on the top and the bottom. If they're the same, we take the numbers in front and we divide them. And then our third option is if the top is less than the bottom. And when that happens, you have a horizontal asymptote of y equals 0. Okay? This will come in handy, so try to remember as much as you can. And then for your vertical asymptote, we're always going to set the denominator, and that's after you've simplified anything. Denominator equal to 0. So we don't want to necessarily set the original denominator to 0. You want to do any factoring and canceling out to simplify first, and then whatever's left in the denominator, set it to 0. Okay, so in this problem that we have here, if I wanted to find the horizontal asymptote, I'm going to check the degree. So the degree of the top is 1, degree of the bottom is 1. So they're the same, so I'm going to do the ratio of the coefficients. So I have 2 over 1. So here, my horizontal asymptote is going to be y equals 2. And then for the vertical asymptote, since nothing can be simplified here, we're just going to take the denominator and set it to 0. So x equals 5 is my vertical asymptote. So when we are working with limits at infinity, we want to try to divide by the highest power in the denominator. And really what all we need to do is think about the horizontal asymptote. So if we look at this limit that we have here, x is approaching infinity. If I look at this function, okay, I'm going to check for a horizontal asymptote. So the degrees are the same. Since the degrees are the same, my horizontal asymptote would be, so I'm just going to write this over here, horizontal asymptote we know would be y equals 3 over 5. So when the limit is approaching infinity, it's just going to equal the horizontal asymptote. So what this limit is 3/5. It's approaching 3/5. Now we could split this up like we did in the previous problem 2 slides ago, and we could rewrite this and make this split up using the limit laws, and then take the denominator of x squared, which is our highest power in the denominator, divide this by x squared, this by x squared, this by x squared, and then like this and this and this by x squared, and plug in infinity. And what happens is all these become 0 because it becomes the denominator is larger. So like x over x squared becomes 0. This becomes 0 because when I plug in infinity. And we really are ending up just looking at that first term anyway. So the trick of the horizontal asymptote will actually make this a little bit easier to understand and a little bit faster. Okay, so let's just look at another one now. So here again, we're plugging in infinity. Well, I'm going to check my degrees. They're the same on the top and the bottom. So this limit is going to be 3/7. Okay, I'm going to look here. Well, now the top is bigger than the bottom. So when the top is bigger than the bottom, we know that the horizontal asymptote, so I'll write this out here, is none. So there is no horizontal asymptote. When that happens, that means that your answer is either going to be infinity or negative infinity. So again, we're going to look at basically the first terms, but we're going to use that rule from the other slide of dividing the highest exponent in the denominator. So the highest exponent here is x to the third. So if I were to divide this, I'm going to have 3/7. I'm just going to take out that constant. And I have x to the 8th over x to the third. That's going to be x to the 5th. So I'm going to pull out that 3/7, and I still have this limit as x approaches negative infinity, but now I'm going to have x to the 5th. Okay, so I'm pretty much just like crossing off this end. Like I'm just not going to even pay attention to that. And we'll see in a minute like why we can do that, but we can. So it really just depends on like the leading terms. The first term on the top and the first term on the bottom are really kind of what tells us what's going to happen here. So I'm going to divide by that x to the 3rd. The 3/7 comes out. Now if I plug in negative infinity, because my exponent is odd, this is going to equal negative infinity. Right? Because I really have 3/7 times negative infinity, which is just negative infinity. Okay, so now this one looks a little bit tricky because we have a square root, but just think about what the denominator is, right? So in the denominator, the highest exponent is x squared, but it's in the radical, right? So what I'm really doing is I'm going to divide everything by the square root of x squared, right? So the square root of x squared is really x, right? So on the top, I'm going to divide everything by x. So I'm going to say that we got the limit as x approaches infinity. So if I divide this, I get 1. If I divide the 2 by x, I get 2 over x. Now in the bottom, because I have the square root, I'm going to use the square root of x squared. So I'm going to make this the square root of just 9, right? Because I'm going to take x squared and divide it by x squared. And then here I have 1 over x squared. Okay, so then if I use direct substitution and I plug in infinity, I have a 1 here. 2 over infinity, well, that's going to be 0 because it's going to get closer and closer to 0. And then on the bottom here, I have 9 plus plug in infinity. 1 over infinity gives me 0. So I have 1 over the square root of 9, which is just 1/3. Okay, so even when we have square roots, we just want to do the same thing and think about what's our highest exponent in the denominator and divide it everywhere. But if it's a square root, just pay attention to the square root. So on the top, you can simplify it and use x because the square root of x squared is x. On the bottom, keep it in the square root since the bottom is already in the square root.